Artificial intelligence is evolving at lightning speed, and Python remains at the forefront of this revolution. Whether you are a beginner or a seasoned AI developer, having the right tools can make all the difference. But what if I told you that mastering just a few Python libraries could supercharge your AI skills? In today's video, we will explore the best Python AI tools you should master. So, our agenda is to cover the core fundamental libraries that you will be using in your AI journey. We mostly deal with the data and then we try to visualize the data to get insights out of it, and then we build AI models around that data. So that's a life cycle, right? So let's see the backbone of data handling using NumPy and pandas, and then we visualize data insights using matplotlib and seaborn. Then we look into ML, machine learning, DL, deep learning libraries for building AI models. We use scikit-learn for classic machine learning, TensorFlow for deep learning, and PyTorch for deep learning. So let's dive in and see with the code. Instead of reviewing the presentation, I'm jumping back into Kaggle notebook and let's review that there. Okay, so this is a Kaggle notebook. I'm going to share this in the resource section in the YouTube description for you, as well as a GitHub link and chapter as well. Okay, so you can read the chapter to get deeper insights with the context, and this particular Kaggle notebook will help you to execute code yourself and understand better. Okay, so it's like a gold rush, you can't extract gold without the right tools, right? So in this similar analogy, you need to have the core libraries from Python to make the best out of Python to generate best AI. So that's the idea. And then this is a presentation that we just reviewed. Anyway, so let's jump into the code and review by hand. So NumPy and pandas are the backbone of data handling. How we can do that? Let's see one example for NumPy. And it a heads up is that it's not exhaustive. It's just to introduce you the core tools, but not the library itself. What we do is, let me introduce the tools first, and then I'll jump in the next video in a deep dive, so that you will learn the libraries or tools later section, right? So this is just an introduction. You will get to know things. It's like a shake hand with the tools. So NumPy is for numerical operations, and it's fast and efficient. That's why we use NumPy for all mathematical operations. And how do you import NumPy? So it's not a okay, so you have to import NumPy. So NumPy as NP is a common convention that we use, and to create an array is, you have to call numpy.array and then open parenthesis. Inside it you create a list of numbers, so that will become your array. So that will be assigned to this particular variable called arr array, and if you print that array, then you will see something like this. So this is NumPy array. You type for yourself what is the type of this array, then you will see that as well. Then some mathematical operations. So we can do a lot of mathematical operations. One of the simpler one is numpy dot square. So square is a method available in numpy. Over this array, if you apply, then the answer would be 1, 1 squared 1, 2 squared 4, 3 squared 9, and so on, right? So that's how you can use numpy for all sorts of mathematical operations. So here is a code example for the same. I'm running over it. As you can see, all expected output has seen now. So as I mentioned, let's see type of array, right? So it's numpy nd array. So this is how you can create array. This is simpler example. Let's stick with simple operations, and when we dive deep into these libraries, we will review the more examples with and complex examples. Okay, with that, we'll jump into pandas. Pandas is for data manipulation. Okay, so how do we create a pandas data frame? Pandas has different data structures, like pandas data frame, pandas series. Okay, so how you can create a data frame is like this. Okay, pandas, you need to import pandas as pd. That's a common convention everyone use, so go with that. And let's create some data in order to create the data frame, right? So it's a structural data, tabular form sort of thing. So you need to have some column names and corresponding data. So what we are doing is our similar example that we have used previously: name, age, city. Three people are there: Alice, Bob, Charlie, and their respective ages and their locations, right? So this is your dictionary, right? Name, a dictionary, list of values; age, key, list of values; city, and list of values. So the previous knowledge is being applied here, and then this dictionary is input to the data frame object. Okay, by pd data frame of data will give you the data frame. So let's see what the output would be. So pandas data frame is this. Okay, so 0 row, first row, second row, column is name, age, city. Okay, so that's your df. If you just print df, that looks like this. Then let's see the matplotlib and seaborn. This is for visualizing data to get insights out of it. Okay, matplotlib is a Swiss Army knife for data visualization, because it's a inbuilt, and you can call it and make any kind of plot. It's a bigger library. You can use it for any kind of plotting purposes. Okay, so how you import it? Import matplotlib dot pyplot as pld. This is what we all use, so let's stick with that. So we need some data in order to plot, right? So let's create a sinusoidal wave. For that, we are using the numpy, which having linearly spaced number generation. So linspace from 0 to 10, 100 numbers. Okay, that's your x-axis, and then using this x, you are trying to get y, which is numpy dot sine of x sinusoidal wave for the x input. That's your y. So what we are trying to do is we are trying to make a plot using this x and y, x-axis, y-axis values, and we are giving sine wave as a label. Then we want to give a title, sine wave plot. These are all bells and whistles. This particular line will give you the chart, but if you want to have some structured printable format, then this will help you. This is standard structure. So title is sine wave plot, x label is x-axis, y label is y-axis, and I want to see legend and plot show will actually show the plot, right? So sine wave plot is this title, and sine wave is this label, and legend will actually show you this color here, and x-axis as you can see here, y-axis as you can see here, and plot show will actually print this, and the curve is sinusoidal as you can see, right? So this is how we can create plots. So that's from matplotlib example. Let's see one example from Seaborn. Seaborn is to have rich visuals. It gives you complex visualization. It has a lot of different techniques to work over string data, numerical data, and you can create different variations in colors to distinguish the data to get more insights out of it. So this is one other beautiful library for data visualization. And for you to test, they have some predefined datasets which you can import very quickly from the library itself and try some methods of plotting. Okay, so how you import Seaborn as SNS. Then I'm putting this set theme to have this kind of white grayish theme, but that's a default theme. And if you don't put it by default, it will come. But if you want to try some different themes, you can try here. However, so how do we load the data? SNS load data set, and it has some data sets. You can get them from the documentation. One of them is tips, and tips is loaded here. And then what I'm trying to do is I'm trying to plot rel plot over this tips data set. That's your data, and what my x would be, x is total bill, y is tip, and column is time. Hue smoker, style smoker, size. Okay, so that's a lot of information. You can just go with x and y, but as I mentioned, it has a rich visualization and multiple options to distinguish the data, right? So these are different aspects of it, so that will help you to make very rich visuals out of your data. So this execution will actually give you this kind of plot. This is total bill, this is tip, x and y axis as you can see, and time, right? So column time, lunch time, dinner time. So the data is split into two sections right here. If we don't mention the column time, then this also incorporated into this, and you will have more data in one plot itself. But this column will help you to separate and visualize this. That's one. And hue is smoker. So smoker, yes or no, there are two distinctions that are separated by blue for yes, this x, or orange for no. So you can see there are many smokers over here, many smokers over here in the linear curve, and these non-smokers are here, and the smokers are scattered around. That's how we can actually see it. Okay, so the size is also another information. So the bigger is a bigger size, right? That's proportional. Smaller is 1, bigger is 6. That's how it is. But you need to know how you're calling these values. Okay, so that you can verify by reviewing the data set. So the data tips is at pandas data frame, which is having 244 rows and 7 columns, out of which you are using total bill and y as tip. Okay, and then the extra information is this: the time is a column that you're using, splitting dinner time, lunch time, and smoker, yes or no, and the size. So those are all the no data points, and we usually plot x and y, but with Seaborn you can actually uh, plot multi-dimensional data. It's not multi-dimensional in a way, but on 2D or 3D plots you can actually distinguish and view the data. Okay, so that's with that we jump into building AI models. Okay, so machine learning and deep learning libraries that we use are scikit-learn is for classical machine learning. You have tabular data and you want to do regression, classification, or supervised learning, unsupervised learning. All such cases you can actually use scikit-learn. So let's try one example. So what we are trying to do is linear regression over Boston housing data set. Okay, for that what we do is we directly read the data from one of the GitHub raw location, and you can use pandas knowledge read CSV. Will read directly from this CSV URL. You can actually download the CSV and pass in over here the path, local path. That also works. So this is your raw df. What I'm trying to do is I'm trying to make, let me show you what is my raw df first. So that's my raw df. My column names are in the lowercase, but I want them to be uppercase. One example I wanted to show you how you can manipulate some data. That's it. Okay, raw df columns, that's how you can access all of this. And these are strings, so string operation, I want to make them upper. So that's how you can chain multiple functions together to manipulate something and overwriting the raw df columns itself. Okay, so that's operation, and you can see raw dfm is transformed just the column names from lowercase to uppercase. That's it. Okay, so this data set has 506 rows and 14 columns. Okay, so let's write that into Boston variable. So because we are dealing with Boston housing data set. Okay, instead of we working over all the 14 columns, to keep it very simple, what I'm trying to do is let's take two columns for x and one target value. Okay, so rm and lstat are my inputs. Rm and lstat are my inputs, and this is output of target. Okay, that's what I want to teach the machine learning model, and I want to predict MEDV, median value, maybe, so that's what I want to predict with regression, right? So instead of using all the data for training, I want to test my model performance. So I want to split my data into training and testing. This train test split will help you to do that. So test size is 20%, that means 80% for training and 20% for testing, and then calling the model. So as we imported already this particular model, I can actually call it and then instantiate here as an object, and then I can call the method fit over my trained data. This is my x and y. Once the training is done, I can make the prediction using the object method, class method predict over my x test. Okay, so this is my test, and that gives me predictions. So since I have already split my data into training and testing, I know x test will have this y test, and I want to make sure whether am I predicting y test accurately or not. That's where we evaluate the model with a metric. Here we are using mean squared error between the y test, the true values, and the predicted values from the model. So that's your mean squared error, and here is the value of mean squared error. Okay, so you can play with this. So this is a template for how you train your model. So you need to have data, you split the data into training and testing, and you have your model imported, fit for the training, predict for the testing. Okay, so that's how you do the modeling in the scikit-learn. So this is one example. It has a lot, we will review later, but let's jump into TensorFlow. So this is your first neural net with the TensorFlow. It's a very simple code. I know on TensorFlow website you can see this example. So you can import TensorFlow as TF, and then it has inbuilt data sets which you can access with methods like this. tfkeras dataset mnist will give you the mnist dataset, and as I mentioned before, split the data into train and test, and do some processing. This is a normalization technique, making sure the values are between zeros and one. That's it. If you think the information is complex, don't worry. You have to see what we are doing: importing the model and getting the data, splitting the data, defining a model, training and testing. These are the steps. Okay, so you have to see the fundamentals, not the minute details. Okay, just see from top view, understand it, and try to apply in the later sections. Okay, this is how you create a model with the TensorFlow, and then the model has to be compiled by passing optimizer, loss function, and metrics. Then you can do the fitting over the training data and evaluate over the test data. So once you run this cell, you will get this output. Okay, and then so this is loss, this is accuracy 97%. That's good. Then I also wanted to show PyTorch. So PyTorch is super cool. I use it on my day-to-day basis. You have full control over it. Like you can define your functions, your neural networks, your loss functions, a lot of there. So there's another popular library, and TensorFlow is coming from Google, and PyTorch is coming from Meta, also known as Facebook, right? So this is how you imported Torch and some other libraries from it, and then you can get the data set from their default data sets, and then the data loader is for loading the data. This is for efficient data loading in the batches, just to save you from overheading lot of memory. That's it. It's a when you use GPUs, it will actually help you better. Anyway, so this is how you define your model, neural network model. So that's your first PyTorch neural net, and then you can, as we learn classes, right? So this is class, and this is a parent class. We are inheriting and we are using super, just repeating what we have learned in the other lecture. Anyway, so this is the object creation using that particular class neural net, and then you define an optimizer, you define a criteria function or loss function, and then you define a function for training, a function for testing. How do we do that? So for a certain number of epochs, get the data from train loader, and make sure you set the optimizer to 0 grad, so you don't have any previous data in there. So model will take the data as input and gives you the output. Simple, straightforward. Y is equal to mx plus c. Criterion will take the output and target, which is the prediction value and the true value, right? So that's your loss function. That's how you compute y true minus y prediction, output minus target. You're trying to throw a rock into a bucket, okay, and how much force you have to apply to throw that into the bucket. If the force is over, it goes out of the bucket, and if that is low and it falls near to you, it doesn't reach the bucket. The force should be appropriate in order to reach that bucket, right? So that's what this loss function will compute. That's an analogy. And then we compute the loss and we try to optimize, appropriate the weight. Based on the feedback, we try to set the weights, and we run this for multiple times. Then we test the model with this particular code, similar code, but we use prediction, how many of them are equal to the target. That will give you the accuracy, right? So that's how you compute your model performance. So training is very simple. You call that function and pass in the arguments: model, train loader, optimizer, criteria, loss function, and how many number of epochs. So for those number of epochs, you will be seeing some printing over here. The loss is going down from 0.4 to 0.2. Okay, so it's a fluctuation. It all depends on the learning rate and how many epochs that you run for. Okay, and when I test this particular model, so I can pass the arguments model and test loader, that will test, and we got almost 97%, 96.95, right? So we're doing good both with the TensorFlow and PyTorch over MNIST dataset. Don't worry, that we will review the details very thoroughly later in the later lectures. But for now, that's enough. That's what I wanted to cover in this lecture. So we have covered mostly all these, like NumPy, Pandas, Matplotlib, Seaborn for data visualization, and MLTL models for building AI models. Especially these three: scikit-learn, TensorFlow, PyTorch, right? Okay, so what you do is use this Kaggle notebook and try to see the code, how I'm importing and all. Try to run this notebook, and if you find any difficulty or if you have any questions, feel free to put that in the comments. Thank you.